Okay, good evening. Am I audible now? Am I audible now? Okay. Yeah. So good evening, everybody. Welcome once again. Sorry for coming late. Sorry for resuming late. Had some technical issues. So you guys are welcome to Data Code Teardown, where we give our community members the opportunity to give us a breakdown of their wonderful projects that's going on, that they have built so far. Mhm. And of course, this segment and program is sponsored by is brought to you by Analytic Sage. And Analytic Sage, an educative platform the main goal where the main goal is to preach the word of data. Let's say the word of data, and then connecting us to what goes on behind the scene production world. Yeah. And today we have the today we have a special guest, the name of Joseph, who is a Web3 developer and a Python expert also, who has done so many. He has worked on wonderful projects, some like LB Community, also a development marketer, development market, and so many exciting stuff. So, so Joseph, if you are active, please kindly stay high, and then we can proceed.
Hello, guys. Thank you for having me. Can anyone hear me, please?
Yeah, good evening. Good evening. Yeah, can you
Right.
go on?
Okay, I'm Joseph Mikaelson, yeah, and I was a part of the Analytic Sage SQL class, and I was also part of the Python for blockchain class that just concluded, and I really learned a lot from that. So the project I'm going to be showing today is actually what I built for my demo project. That's what I'm going to be showing today. Let me share my screen now so that I can begin.
Joseph, we can't see your screen yet.
Yes, I'm trying to share it now. Can you see it now? Can you see my screen now?
Yeah, we can see, but I don't. It's not showing live here yet. So it's not supposed to add things. Okay.
Let me try sharing it again. Hello guys, can you see my screen now? Okay, I believe it's live now. All right, can you hear me please? Let me know if my audio is in check.
Yeah, we can hear you. We can hear you. Go on.
All right, okay. So this is the project I built for my demo. The front end is actually very simple. The project, what it does is it picks events from prediction markets. Like for my case, I used Polymarket, just Polymarket for now. It picks events from there and it runs it through an LLM, an AI model. And I prompt the AI model to tell me what it thinks about the event and what the possible odds are for the event. Then I use that and compare it with what the actual odds on the live odds on the event page are, and I try to detect if the live odds that are on the event page are mispriced or if they are priced correctly. So there are two segments here. This is the mispriced market. Here it shows you markets that are mispriced and it tells you this is underpriced by this amount, and it also gives you a signal buy yes or sell no. So if you're holding no, sell it. If you aren't holding any at all, or if you want to, you can buy yes. And I also show the volume here, liquidity, and the end date for the particular market. The second part here is the whale signal. What this does is you pass in a link, any Polymarket event link. I'll take this, then click on analyze.
Joseph, I don't know.
Yes,
Are you saying something or we no longer hear you?
yes, I'm trying to get up the second page. All right, so while the API is starting up, all right, we'll signal here. Like I said, if you paste in an event link to a Polymarket event and click on analyze, what it does is it detects whale signal. It tells you what whales are buying, which of the sides of the markets that whales are buying. As you can see here, it says the market with token. This is the token ID for that market. It says it has 20 whales buying yes. That's the yes option for a binary market. And it has one whale buying no. This is the token ID for the no. So as we all know in crypto, whales always have early information and they can move quickly. So knowing what whales are buying into would help you move like a whale, even if you're not necessarily a whale, but you will move like a whale because you know what they're buying into. As you can see here, 20 whales are buying yes, and just one whale is buying no. So you already know where to put your money in. So I'll take us to the back end now. And as you can see, demo project to show that it was my demo project. There are a couple of files here, and I will go through each of them to explain the code behind each of them. So first, I want to start with the predictions market. Right. For this what I did here was for the predictions market. These are the packages I use, the libraries I use. I use datetime, HTTPX, async.io, and I also imported pandas. HTTPX here works with async.io. Normally, most people that are performing network requests, like you're trying to call an API or make any network request of sorts, they usually use requests. But I'll show you in a bit why I didn't use requests. So in this case, right here, we are defining some variables. These are some constants I use for minimum volume and minimum liquidity. I also set the minimum end date and the maximum end date that I want this to produce. Now, this is the API endpoint for the Polymarket market. This is the market endpoint. And these are the parameters that I'm going to be sending to this endpoint. This is the parameters here are sort of a filter. I am trying to get data from this endpoint. These are the filters I am putting in. As you can see here, the variables I created, minimum end date, I fixed it here. Maximum end date, mean volume, mean liquidity, all of that here. Then ascending is equal to true, so I can sort it in an ascending order. Right here, I created an empty list. This is a list that I'm going to fill in with data later. So I created an empty list outside of my function. Now, this function I created is what is called a coroutine. Normally, if you're creating a function in Python, you just use def, the name of function, and the brackets. But right here, I used async before defining the function. What this here does, this word here, what it does is it turns this to what's called a coroutine. A coroutine now helps. What a coroutine does is that the function or whatever you're running doesn't block other code that is supposed to run. Normally, what Python does or what any programming language does is that it runs code from top to bottom. And if it's running a particular line of code, you can't do any other thing while that particular thing is running, right? But what async here does is that it allows for other code to be run while a particular code is running, a particular task is running. And that task has to be asynchronous for it to run. And that is why I didn't use request here. HTTPX is also like request. It's also a library for um, using making network requests, but it is asynchronous in nature. there are some functions here I cannot perform with the request library. So I use HTTPX for that. So when using HTTPX, we use what is called a context manager. This is what is a context manager from with HTTP client at client. When you start something with and continue this way, this is called a context manager in Python. And as you can see here, async, that's also trying to make this context manager asynchronous. And whatever we want to await, whatever we want to make asynchronous, any task we want to await while the task is running, we want it to wait in the background so that other tasks can run. Right? Whatever we are doing, we want it to wait in the background instead of taking up space in the foreground and blocking every other thing that wants to happen. We want it to do its thing in the background, and whenever it's done and it gets the results that we want, it then sends the result to us and we retrieve the results there. So my response here, and I create a variable here, response, because I'm trying to get a response from this endpoint. The keyword to tell Python the process you want to put in the background is await. When you put await before the function you're calling or whatever you're doing, Python knows that okay, the event loop, what we call the event loop, knows that this is what we want to send to the background and make it wait. So the network request I am making to the API, as you can see here, the gamma URL, that's it here. That's what I passed in here, and the gamma param, sort of the filters I used are what here. The params are parameters. So when I get the response back, I convert it to a JSON using .json and the brackets here and save that in data. Then I create a for loop because when you get the data back or the response back as a JSON, it's not just normally it's not just one thing that is in that JSON. The JSON is like a dictionary, a Python dictionary. It's not just one element that might be inside of it. There will be many elements there. So I use a for loop to loop inside of that JSON and get each element that is inside of there. An element is just an item that is inside the dictionary. If I create a list like the list I have here, if I say 1, 2, 3, all of these are elements. 1 is an element or an object, whatever I decide to call it. 2 is an element. So this list has 3 elements in it. If I want to get all the elements inside of here, I want to get each element, I'll use a for loop to loop inside of this. When it loops one time, it gets 1. When it loops the second time, it gets 2, and so on. So that's basically the idea here for the for loop. So for item in data, the item here could be anything. I could probably use another word. Let's say for A, use anything. But since I have used item in all of this, I will stick to that. For item in data, that's this data here. That's the JSON I got from the network request. If item outcomes, putting these items now, like I said before, it's a dictionary. And how we get something from a dictionary is by using this square bracket and passing in the dictionary key. That's how we get the value. When we get this is the dictionary, this is the key for the particular value we are looking for. That's how we get the value out of a dictionary. If that particular key is not equal to, this is the operator for not equal to, then yes or no as a string, it should append it inside of this. These are also, as you can see, item ID. We had one key here, item outcomes. Here we have item ID, item question, item description. So all of these are keys. They are the keys to a particular value I'm looking for. Maybe I'm trying to get the description of the market. I ask for item description. All of these they are in the Polymarket documentation. It's unique for each API you're calling. Different API endpoints have the way they structure there. So that's why it's important to go through the API documentation first so that I can understand what you're looking. This is not generic, it's not general, right? It's tailored to the API. That's how the developers created it. So this market details, the empty list I created before, I use the append function to append this. I created another dictionary inside of this. Is a dictionary. A dictionary is identified by curly braces here. This is where it starts and this is where it ends. So I use the append function to append this dictionary each time this for loop runs. So when it gets the first item from this data here, it checks this condition. If the condition is satisfied, it enters here and does this, appends this to the list here. The first time it goes in, it appends whatever result it gets into this list. The second time it goes in until it runs out of objects in this data here, the list or whatever was there. So when I get this as a list of dictionaries. What this will look like when it's done will look something like we have a dictionary inside of this, another dictionary inside of it, another dictionary inside of it. It will just be a list consisting of many different dictionaries inside of it. So when I get all of that, I convert it. That the reason I imported pandas now is because I want to convert this into a pandas data frame. So df here for data frame and pd, that's pandas dot data frame market details, this market details list. Using this function here, I call this class and pass in market details. So it converts that list of dictionaries into a pandas data frame, because for me and how I was working, a pandas data frame will be easier for me to handle. Then since this is a function, I want to get back this data frame from this function. I use the keyword return df. So whenever I call this function get market, and whenever I call that function, what I will get back is this data frame, because that's what I returned from here. Then this if name is equal to main async io.run. This is the event loop here. This is where the event loop starts for any asynchronous code. Now, one thing about this is that I didn't necessarily need to make this asynchronous, but because I am going to be developing further in future, I decided to make it asynchronous from the start so that I don't have to refactor my code whenever I want it to be asynchronous. I don't have to start refactoring my code and changing it from request to HTTPX. So from the start, from the go, I already made it asynchronous. So this is the part that gets this particular file just gets details from the Polymarket API. It gets the market data we need. This is the file that gets the market data. The next file here is true probability estimator. This is where we use the AI API. This is the engine that thinks and returns what the AI thinks should be the best odd for that particular market based on the current event. And for this, I use .m async grok. This here is the AI model I am using. OS for operating system, and I also used async IO. So what load.m does is that if you're working with things like this, you have what's called an API key for you to be able to access this. And you're not supposed to hard code your API key. What I mean by hard code, if you come inside here and type API key is equal to, let's say this is your key, you've hard coded this into your file. And let's say you send this to GitHub, you push this to GitHub. Anybody can view your file, even if you think your stuff is private. I think GitHub was hacked a little while ago, and some repositories that were private were leaked. So if your repository gets leaked and someone, or maybe your repository is public from the start, someone gets your API key, they can use your API key to do whatever they want to do. And let's say if you use AI models often, you know that you have a particular number of tokens attached to your API key and you're paying money for that. So if someone gets access to your API key now, they can use your API key as they like. I saw in news one time a student had his API key leaked, his Gemini API key leaked, and at the end of the month, he didn't even know. At the end of the month, he got a bill of over $80,000 that he has to pay for kind of like an overcharge for the excess or the extra tokens he had been using. So your API key is not supposed to be hard coded into your code. You store it in what's called an environment file. This here is my environment file. I'm not going to be opening this because my API keys are inside of there and I don't have the strength to rotate them if I open this. So I am not going to be opening this file because they contain my API keys. So what you do now is when you've stored your API keys as a variable inside of this environment file here, your API keys become an environment variable. The environment file is .env. That's just the simplest way to create an environment file, .env. Now, when you call, we've imported load.env from .env import load.env. Load.env is a function inside of this library. So when we call load.env here, what it does is that it loads environment files and brings them into this our particular file here. So all the environment variables that were inside of this env file, they've been brought into this file that we are working in, this true prob estimator. Then how we tap into each of them is, now I'm creating another variable, grok API key, and we use os.getEnv, that's get environment. And inside of here, I use grok API key because this particular grok API key here now is the name of the variable that was inside of here. I didn't use this because of this here. I didn't use grok API key here because of grok API key here. I could have decided to name this whatever I like, maybe grok API or anything I like. But I just use that because I don't want to work with too many variables and cloud up my mind. I just want something I can remember easily. So grok API key, and we use os.getEnv. This here now reveals, it then creates it brings out the particular API key we are looking for. That's the grok API key from this environment file. This here loaded all of the environment keys that are inside here into this file, and this line here brings this particular one that we are looking for and attaches it to this variable. So for this, I used for the grok API, I used async grok because I also, like I stated before, I want this to be asynchronous. And now I'm going to show you for this particular one, for the LLM part, the AI side, I actually needed to make it asynchronous, and I'm going to show you why, how it makes everything faster and easier. So I used async grok and labeled it as my client. So from their documentation, as I was reading, this is how you're supposed to use it. So what I did was I created another function here. This here takes in the question. This is a function here, an asynchronous function, also known as a coroutine. This function takes in two arguments. These are parameters here. When you pass them into the function when calling it, it's called an argument. But when you're creating the function, they are called parameters. And this is my prompt, as you can see here. The prompt. This is my prompt. You are an expert prediction market forecaster. Estimate the true probability, real number between 0 and 1 that this event will happen. Then the question here is this curly braces. This is called an F string, as you can see here. This F. What an F string does is that it allows you to pass variables into a string. If you're creating a string, let's say you create a normal string. This, if we want to pass in, say, this client now, we can't pass it in normally. Let's say client is equal to, there's no way we can pass in the other client, this client variable here, because this is just a normal string, even if we envelope it inside of curly braces. But once we convert this to an F string easily by just putting F outside of here, you can see this highlights, this changes color from this other string here. This here is just a normal string. The Python will interpret this as you've written it here to interpret this as client. But this now, Python will have to go and look for a variable called client inside of your code. And as you can see, we have a variable client here. So it picks that instead of just interpreting this as a normal, as a literal string. So that's what we've done here. This question here is this question that we passed in as an argument. The same thing we end it. This question end it here, they are just literal strings. Then think step by step, return only the final answer. Don't hallucinate. I did all of this so that because as we know, AI models are probabilistic. They hallucinate a lot and they can give you what is not even what you can't find anywhere to just make up its own answers. That's why I said don't hallucinate. Here I did a try. I did what's called error handling here, just in case when you're making requests to APIs or whatever, not just requests, many things you're doing, they can fail. Maybe you've not considered a particular thing and that event happens, or that whatever can go wrong may actually go wrong. So let's say something goes wrong, your code will break, your code will fail. What we do to avoid that is using try except. This is a error handling method. We use try here. Try whatever is under the try block is what Python should try. This is what we want to do. This is actually what we want to do. So we want Python to try this. But if this fails now, that's when you have except. Try this, except something happens. Except exception. This exception is what went wrong here. Let's say you were doing something, then you get exception like list out of range or out of range index, something like that. That's what will be inside of this exception. So try this, except this exception happens. So we are storing this exception as E. Then we are telling down here if there's any exception here, any reason why this doesn't run smoothly, print out that reason here so that we can know what's going to happen. And what I did down here was that if there's any error from here, it should print that and then return a fixed amount. This is a constant I asked it to return so that my my app doesn't just break, because there are sometimes you would see something fails, you don't know what failed, and it reflects on the front end or the user side that something had failed. But using this exception handling, the user might not necessarily know that something had failed, but you're the developer and you're monitoring it, you see from your logs or from the print screen, your console, it prints this error. You know that okay, something broke. And for the client, it returned this. So the client doesn't know that anything went wrong. Now moving on to the whales versus retails file. I also imported async IO and HTTPX. But another thing I did was from predictions market, import get market. I imported a function here from predictions markets. Normally, ever since we've been importing libraries and packages that are external from people that created it outside. But this time I imported my own file into another file. So from predictions market, I imported this get markets function. This prediction markets file, I imported get markets function into this. And I imported async IO and HTTPX as I've been doing before. So this is another one of Polymarket's API endpoints. This one is for holders. The one we had before was for the market. We're trying to get the market, but this particular one is for holders. When I showed you before the whales side of that of my front end, where I said how many whales were holding this token and all of that, this is where I get that from. Right. So what I did here was I defined a function get whales, and I passed in the link as an argument. This link here is going to be this. That's the link I'm passing into that. So slug here, I did some handling. Many times I tried to get the slug. Now what Polymarket, this API is taking as a filter, like I mentioned here when I was talking about parameters, this params here, what this one is taking, because that's what I want, is the slug. The slug now is the part of the link that when you remove this whole side from that link, the remaining part is called the slug. This is just a generic link. It will lead you to just the Polymarket general page, but that particular slug identifies the particular event you're looking for. That's what the slug is. So client here is the httpx.clients that we created. We initialize this class. We instantiate this class. This is a class, this client, and here it's a class. We instantiate it, create an object from it. This is, at this point, this is just object-oriented programming, but we don't need to get into it. It's something that if you study further into Python, it's something that you will need to know, and it's something that will help you when you're building object-oriented programming, where you use classes and objects. So we are instantiating this class into this object, and our response, like we did before, response, we do the client.get and send a network request to this URL, to this endpoint. Then what we get here, remember, okay, from here, the .json, I just labeled it as data. You can label it as anything you want to label. Here, I labeled it as events because what I'm getting here is Polymarket events. So I just labeled it as that so that it will be easier to remember and easy to work with. Somebody that is reading my code would understand what I was doing, would see that, okay, this variable is events. This is what, because it was for this and all of that. So market details, event, market. I mentioned before that we'll be getting a dictionary, and this is how you get values from a dictionary. You use the name of the dictionary and the key for that particular value that you're looking for. I also created a blank list here for questions and an empty list here for condition ID too, because I'm going to fill them in later. So for markets, in market details, this market details that I got here, what we are going to be doing is questions, these questions that I created an empty list for, dot append, and we are appending market condition, the market condition ID and the market question. The same thing I did here, why I did all of this, is the same thing we are doing inside of here. This one is just shorter because I don't need too much information. I just need the market condition ID and the market question. And for condition ID, the only thing I'm appending to it is the condition ID. I used condition ID and question here because from the Polymarket API, there is another endpoint that you can use to get some data, some details based on the condition ID. That's why I created this. So when you're designing how your program would go and you understand the different endpoints, you would know what you want to get and how to structure it so that you can refer to it later. So I also created params here, and these are the parameters I want to use for what I'm going to do next. I have made one request here. I'm going to make another one here. So this here is the parameters I created, market condition ID. As you can see, that's why I was getting condition ID here. So this condition ID, what I did to it was I sliced the link, or I sliced the list rather, because the list was very long and there is no way I could have sent that whole list over a network request. I would get an error. So what I did, this thing here is called list slicing. What I did was that I told it to start from the beginning and get the first 20 elements inside of that list. So that's what I have here. If I wanted it to start from the second position, what I'll put here is 1. Because in Python, everything you're counting starts, not just Python programming, everything you're counting starts from 0. So the first element is 0, the second element is 1, right? So If I wanted it to start from the second element, I will put 1 here. If I wanted to start from the third element, I'll put 2. But I want it to start from the first element, the first object. So I don't necessarily need to put anything here. So I either leave this blank or I put 0. But I'll just leave that blank as convention. And the 20 here is the amount I want it to get, the number of elements from that list I want it to get. So I'm slicing this list from over 200 items in the list to just 20 items in the list. Then I set a limit here and minimum balance. This is the minimum balance that I set. All of this is based on your discretion and what you're building. So what I did here again was to create another request, an asynchronous request this time. And what I got the response from there. Then from the response, I also created the JSON again. Then feedback is an empty list. I looked through the response I got. Same way we look through the response every other time. I looked through the response, and for this feedback empty list, these are the things I appended into the list. This is what I needed. As you can see, a token, item, and the token here. That's the token we saw when I was explaining the front end side of it. This is the token we saw, number of holders. Before we saw that it was 20 holders for the yes, 1 holder for the no. This is how we get it because it returns a list now. This will return a list of holders. All I need to do is just find the length of that list, and I'll know how many holders there are. Like if you have a list of people, you have a list of a person named A, person named B, and person named C. There are 3 people in this list, but let's say you are blind and you don't know, you cannot count it by yourself. What you just need to do is find the length using the function len. You just use the length function like I used here to get the length of this list. Then the outcome index, and this is the message I created. The market with token this, has length this, whales buying. Yes, and I set some conditions here. If item holders this, else no. And this here I did it through an F string. As you can see, the rest here are normal strings. Like this yes is a normal string. This no is a normal string here, but this particular one, since I wanted to get in some variables inside of this, I had to use an F string to do that. And for this function, this get whales, what I returned from it was feedback. That's this feedback list. And I also did if name is equal to this. This is another topic on its own. Then async io.run. Whenever you're running a coroutine or an events loop, you don't just run it normally by tapping on this button or using Python run. This is what you do. This is what you do here. If this is not included, this will not run. This is what tells it to run. Now we are moving over to the main side where I aggregate everything I have been building here. Everything in this other file. This is where I aggregate all of them. So I defined another function here, still an asynchronous function. I defined it here as main, and I created a task, get market task. Now, whenever you're trying to create, whenever you're working on coroutines, with coroutines and asynchronous code, what you have to do is create task first. Async.io.create task. For other parts, I didn't need to use, like I mentioned here, I didn't necessarily need to make it asynchronous at this level I am working on as a demo yet. That's why I didn't use create task, the create task I'm using here. But for this, I just decided to create a task. Now, if you're doing an asynchronous code and you don't create task, if you just await it directly, what it will do is that it won't function as it should. It won't function as an asynchronous code. It will just function as a normal code. It will run like a normal code. It would run like, so the person that is viewing it will just run as a normal code. So what we do here is we create task before we use await. If you use await without creating task, it will just pick that particular function you want to run and just run it without, it won't have anything waiting in the background. I explained that when we are using asynchronous code, it means we have something else we want to run while this particular function is running in the background. But if we don't create task first, once it gets to the point where it's awaiting the code, it's running the code, and it checks the event loop. It checks for anything that is ready to run. It doesn't see any other task that is ready to run. So it just runs this one till it finishes, and you won't be able to do any other thing. So if we had another thing that we wanted to run while this one here was running, if we had another thing we wanted to run, we'll also create a task for that. Let's say second task. We'll also do async io.create task for whatever that is. We'll just do async io create task, then pass in the second task we want to run. But we don't have a second task here. So after we've created this task, what we do now is to await that task. We are awaiting. What we mean by await is that we send it to the background and await a response from it. We tell it, okay, run in the background. Don't disturb whatever is going on in the foreground, or don't disturb any other task that is supposed to be running. Just run in the background. Whenever you have a result, get back to us. We'll pick the results from you. So for that, I stored it in this variable market. And before this get market, where is that? The get market here, remember I returned a data frame, a pandas data frame. This is the get market function, and this is what I returned. So when I am running this get market here, when I run it here, what I will get back inside of this market is a pandas data frame. So that's what I got inside of this market, and it's basically just a table, right? A data frame is just a table like you have in Excel or Dune Analytics. A data frame is just a table. So what I did here was I trimmed that data frame to get just the first five rows of that data frame. That's why I used the function head and passed in 5. Why I did that was so that I can reduce the amount of questions I am sending to the AI model, because I have a limited number of tokens I can use, and I didn't want to send it every question that I am getting. So what I did, an intelligent solution I made, was just to trim that head from the start. Then I printed market. Most times we use print so that we can check what our code is doing in case it breaks anywhere. Most most developers in general, they don't necessarily use debugging tools. Print is our main debugging tool. You print it to see what's going on. So I printed markets to make sure that I have gotten what I want to get, and it's actually what I was expecting. Then what I did here was if not market.empty. What this does is that it checks if market is empty. This market I'm returning here, like I said before, there are errors that you may not be able to foresee. You might not know that maybe as you're getting this market back, the data frame would be empty. So if it's empty now, you'll not be able to run some kind of function or filtering on it because it's empty. There's nothing inside of it. So all your other code, if I had just done this without checking if the market was empty, if I'd done all of this, if the market was empty, this would return an error. I'll get an error here, and my whole app would break just because of this small thing, and because the market was empty. There was no data frame returned. So what I did was, if not markets.empty, another way I could write this would be, say, if markets, let's just say if markets, this is a boolean, it returns true or false. If markets, if there's anything inside of this market, it will return true. Then it will run everything that is inside of this. But since I've already used that, let me continue with that. So if market is not empty, run all of this. This else now is if the market is empty, return no markets found, right? But if the market is not empty, run all of this. Here we have the questions, and all of this is basically just what we've been showing before. we are getting back a dictionary. So we are using the dictionary key to get whatever we want, and using this to list function to convert all of it to a list. So what I did here now, this is where the asynchronous code really shines in my whole program. For now, this is where it really shows what it can do. Normally, when I look through, say I'm looping through any of this, maybe I got market questions, I got the questions I wanted. I could have decided to just look through the questions, each question, and send a request to this. But that will be very slow, because every time a request takes time to send a request and get the answer. And while it's sending the request, you can't do any other thing. You can only, and if I had done the loop, I'd have only been able to send one request at a time. So let's say, for example, one request takes 5 seconds. So for the five, because I trimmed it to five, yeah, you're sending five requests. It will take a whole 25 seconds. And on the user side, maybe for you, if you're a starting developer, you might think, oh, it's just 25 seconds. But imagine you're using an app and the app takes a whole 25 seconds to load and show results. You'll be frustrated. And that won't be a very good user experience. So what I did here was to create what's called a task group. What a task group in asynchronous programming does is that it takes all the tasks, like you see this task we created here. This is one task. We could create another task and all of that. What a task group does is that it creates multiple tasks inside of it, and it awaits each of them. So what this is doing is almost the same thing as just looping through this and sending one request at a time. But what it does here now is that when it sends the first request, it passes that process to the background and sends another request and passes that to the background and tells it to await. Anytime you get a response, let me know. So it sends all, like I mentioned before, let's say if one request takes 5 seconds to get the request from the API and return to you. If you're making five requests, that will take a total of 25 seconds. But for this now, since it it tells each request to not block what the other one wants to do, all the requests would run at the same time. So with this little line of code, I have saved us from using 25 seconds to make all the requests to just using 5 seconds. That's the time for each request. So it will feel like we are using the time for just one request to run five requests. That's what the task group does here. It groups all of the tasks into and makes it look like one and runs all of them together at the same time. While one is waiting in the background, another one is running at the same time. Instead of each of them running one after the other, they are running in parallel. They are running in parallel, running at the same time. So that's what this does. The other ways we could do this, we could use what's called gather. There's another function called gather in async IO, but for personal and some technical reasons, I prefer to use a task group, and this is not something I want to get into now. It's asynchronous programming is a whole 2 hours topic on its own, or even more. That's a whole topic on its own. So it's something you can look into. So for the edge here, I just calculated the estimated odds and did some calculations based on what I got from the AI, from the API I made, the API call I made to the AI model. I made that here. This the API call I made to that model. I just did the estimate here, estimated odds. That's what it is here. I subtracted this from that, and that was my edge. That's the edge I got. When I subtract one from the other, what the difference from that subtraction is the edge, the market edge. Then the suggestion here, I created an empty list still, and I did some conditional. I wrote some conditionals here. If the number is less than 0, that's if it's in the negative because of this subtraction I'm doing. If it returns to the negative, turn it to an absolute, and this is the suggestion you should make. All of that, I appended it into this. Then I created a dictionary here, and this is the dictionary. This is the key, and this is the value, key value. So, like I was explaining with dictionaries, where you use the name of the dictionary and the key for that particular value. That's the same thing we'll do here. If you want to grab this question from here, what we'll do, okay, let me use ID, since question and question look alike here. So if you want to grab ID, whatever the ID here is, what we'll do is dict. As you can see, the name of my dictionary here is dict. Let's and IDs. You can see that this is the key here. This IDs is the key that we will use to get this value. What we are looking for is ID here, but we are using the keys IDs. Right, this is the name, this dict here is the name of the dictionary here. And yeah, so why I'm getting red here is because I defined dictionary inside here. This dictionary variable is a local variable. It's only available inside of this function. We can't use it outside of the function, right? This dictionary doesn't exist outside of the function, but this is just an example that I'm showing you. And we also did if name is equal to main async IO run. Remember, async IO run main, that's this function. You pass in the function you want to run into this. So that's how we built the app. That's basically the app that we've done the prediction market, the probability estimator, whales versus retail. That's the whale signal. And that now what we are going to get into is the API side. The side you're able to call, the side that returns whatever it returns to the front end, the side that returns data, actually, because all of this, it's not really useful if we cannot return it to a front end, right? If users cannot use it on the front end, or if somebody cannot get the data out of it, we'll only be printing it to our console, and that's not what we want to do. So for the API side, I used Fast API. That's the standard for Python. I used Fast API. I made some imports, context lib and async context manager. And I used Fast API. I imported Fast API class from Fast API. Now you can see me importing Fast API from Fast API. The difference here is that this Fast API here is a package. Let's say we have demo project here. This demo project is the same thing as this Fast API here, this particular one that is highlighted here. That's this demo project here. That's what we are trying to import from this. So this is just a package. Then this is something inside of that package. This is a class. How we identify class is by the naming. For this one, you can see that everything is in lowercase. But anytime you're naming a class, a convention is the first letter of each word. You don't separate it with anything. The first letter of each word has to be capitalized. Normally, if we are naming something in Python, let's say I want to name, let's say, student name. For this, I used this underscore to separate the two words. If I'm naming a variable, this is called a snake case. When you're separating something with an underscore, it's called snake case. But for this, we are not separating with any separator. How we separate it is by capitalizing the first letter of each word. For fast, we capitalized F. For API, since API is an abbreviation, we capitalized everything. We capitalize A, capitalize P, capitalize I. Same thing here. This is also a class. We capitalize fast here, F in fast here. We capitalize the whole of API. Then we also capitalize C in cache. This cache here. So that's how you spot something that is a class. This is called Pavlov case. This type of casing is called Pavlov case. These are some conventions you have to know if you're going to be a better developer, because there are conventions we use. That's why I'm able to identify that something is a class immediately, because the person that developed this knew the convention and they used the convention for this and named it using a Pavlov case. It's not a rule. You can decide to name your class without using this, but as a convention, developers, that's how we do it. So from main, I also imported main here, as you can see. I imported main here. Then from whales versus retails, that's this. I imported get whales. That's the function inside of that. From main, that's this main here. I imported main. The main I imported is this function now. Now this is the side we create the route and the API itself, what the API will return depending on the route that you pass in. First thing we did was lifespan. This is just a cache, because I don't want to be hitting these functions every time, especially the this. I don't want to be hitting this too much, since, as I said before, I have a limited number of tokens I can use, and it renews every day or something. I really can't remember, but for a particular time I have a limited number of tokens I can use, and if I exhaust that, my app will crash, except I create a backup. But since this was just a demo, I didn't create a backup token that it should fall back to, or some kind of fallback token. Yeah, I didn't create that. So what I did here is to use this. I used the cache here. As you can see, this is where I call the cache and passed in this expire is equal to 7200 seconds. These are seconds. That's about, I can't even calculate how many hours right now, but I calculated it to some extent, so that's why I was able to put 7200 here. But I think this is too much. You can reduce it or increase it depending on, that's at your discretion, how often you want fresh data, right? This cache now, what it does is, whenever someone calls this particular endpoint, this mispriced endpoint, okay, let's take a look at a URL. For example, you have a URL like google.com. This is the base URL. Then you have path, what's called path, or PATH, that's path, right? This will just lead you to google.com. Then you have a path. Let's say you're Googling Python, google.com/Python. This will now take you to a Google search for Python. Maybe you're looking for something related to Python. This will take you to a Google search for Python, anything related to Python and all of that. This is what's called path. So that's what we are creating here. This particular path now that doesn't have anything attached to it is just this forward slash. Yeah, just this forward slash. This is home. Let's say we are using google.com again. Just typing google.com is the same thing as typing google.com/. It will take you to the same page, right? So this is home. That's why I named this function home. You can decide to name this function whatever you want, but I named it home for easy readability. Remember, I always mention easy readability. I want my code to always be readable. I'm not over engineering or doing anything. I want it to be readable. If I come back 10 months from now and check it again, I want to understand it at a glance. Easy readability is the best thing. If you want to scale your code, you want to scale your app or whatever, understanding what happened before, what you wrote before, is what will help you to understand what you're going to do next. So easy readability is key when you're writing code. There's no need to make your code look too verbose or make it look too confusing. It doesn't help you in the long run. So app.get, this app.get is called a decorator. I won't get into decorators because that one is also a topic on its own. It's something you can read about. So we use a decorator here, app.get, and passed in, this is the path we want. This part is for home. We passed in home. So if somebody just visits our app and doesn't go to a particular page on that app, it just visits the main page, the landing page, right? That's the home, the landing page where you just land. That landing page will just show them. I did return message, hello world. So this is what I'm returning. I could return a bunch of things. I could even return a full home screen with HTML and CSS, but that's not what I'm trying to do. So I just returned hello world. Let's see if we can test that out. Mm. So yes, this is the URL for that page. So while it's waking up, let's check other things. So this is the home page, and these are other endpoints. These are path endpoints. This is for the mispriced. I named it mispriced because it's for the mispriced odds. Then I call the function get mispriced, as we've used before. The get mispriced function, I created the get. I can't remember which of the files. I don't want to start searching for it now. But okay, I'm creating this right now. Rather, I am not calling it. This is why I'm creating it. That's why we have def here. I'm not calling it right now. So I created it as an async function still because this from the start, this particular function here, main, is asynchronous. So whenever something starts off as asynchronous, whenever you're using it, it has to always be asynchronous. Wherever you're putting it in, you have to make it asynchronous. So I use async def here to create a coroutine. Then I also did try exception to catch any exceptions. We did results equals await. Remember, anytime you're calling an asynchronous function, a coroutine, you have to await it. Anytime you're calling a task, you have to await it so that it sends it to the background. If you don't await it, you might get an error. Let's see what's happening if we take this up. Or you might not get an error message yet, but if you run it, it's either you will get an error or it won't run as an asynchronous function. It will just run as a normal function, which is a complete waste. And that's not what we want. So this function, I asked it to try this. The result here, await main. That's the function. We remember we imported main here. This function that I imported, this particular main, is what I am running here. I am calling the function here. As I imported it here, I didn't add the brackets because if you add a bracket to a function, it means you are calling the function. And I didn't want to call the function here. I don't want to call the main function here. As you can see, as I'm hovering over it, it's then showing me that this main is an async function, a coroutine, like I've been mentioning before. So anytime you put these brackets after a function name, after the name of a function, it means you're trying to call that function. And that's when every code that is inside of the function starts to execute. So result is equal to await main, and we return the result. Every time you write a function, if it's doing something, if you want to get an output from a function, you use return to get an output from that function. And I want to get an output from this get mispriced function. That's this result. That's why I'm returning result. But if there's any reason why this doesn't run, if there's any error, we catch that exception here and return the exception with status field. We return the exception on the front end and get the status field here. So this here is also, this is another path whale signal. This whale signal is where we get that this number of whales bought this amount, or this number of whales bought this token and all of that. That's what we are doing here. Now, for this link path, what I am doing here, why we have curly braces here, is because I don't know what might enter here when the user is searching this link. Okay, this has loaded up. As you can see, this is the home page. And what it returned here for me was hello world. If I go to / mispriced and enter, Sorry, not that. It takes me to another path, and this is another. I'm getting another data because I've gotten to another endpoint entirely. Still from that API, but a different endpoint. I am getting different data. But for the home page, all I'm getting is hello world. That's all I want to get from there. So this particular whale signal, since as I was showing on the front end, we have a field here where users can impute things. I don't know what the user would impute inside. So I want to get that thing that the user is imputing inside. I don't know what's now. If we go forward again, let's impute this and analyze again. As you can see now, focus on the link here. You can see the link that it has taken, the link that was imputed inside of this. This is the link here, this path. Right, this link was, I don't know the link. I can't predict the link that the user would decide to put inside, but I want to be able to catch that link that the user is putting inside. That's why I use this here. That's why I use this curly braces. It catches whatever comes after this whale signal in the whole URL. So that link, this link path here would be, I took it inside of this as the link. This link path that the user put inside of there, I took it here as the link. Then I did it another try and all of that. I got await get whales. The function I created here, get whales. And this link is the link I got from here, from the user, the link the user put inside. So you can see how you can catch whatever the user is trying to put when they are using the browser side, that's the client side. Whatever the user is putting inside of there, you can catch it inside of your code. You don't know what the user is going to put, but you're going to be able to catch it if you use this. This is how you catch it. And for different Python libraries, there are different methods you use for this. So I was able to catch that, and that's why, and I've been able to pass it into my function here and run all of this on the link that the user imputed inside of that. So when I do all of that, I run this function, I wait it. When it's done, I return the result. And that result that I returned is what we are getting inside of this. That result I returned is what we got here. The result I returned, that's what we are getting here as the output data. So that's really it. And one thing, if you're using Fast API, one thing I learned is that if you're installing, when we are installing packages in Python, we use pip install. There are other ways to install packages. Maybe you add UV add and all of that, but the most popular one is pip install. Many people could just decide to do install Fast API, and this is fine. This is totally fine. But in some cases, you might want to use some other packages like Ginger, for example. There's another package called Ginger that people most times use alongside Fast API. They also use it alongside Flask, right? So instead of just installing Fast API, then you have to come and do install Ginger too. Instead of doing all of that, you can do install Fast API, then square brackets, you put in standard. What this does now is that it installs, there is a standard package for Fast API that installs many other packages that you may depend on while using Fast API. So this is just something you can use instead of installing one after the other, you just use Fast API standard and it installs most of the packages you may think of using while using Fast API. It installs Ginger. Ginger is used to render HTML and CSS inside of Fast API, but I didn't use that here. So that's basically it for this. And I hope you enjoyed the presentation because I enjoyed building this, I enjoyed working on this. I hope you enjoyed the presentation. And okay, another thing you have to know is git ignore. This just tells you that if you have any changes to your code, you can Hey guys. Markets.